Hello, what's up guys? Rian again here. Welcome to the last part of our data representation lecture series, part 2. So in this part of our lecture series, we're going to tackle up on the IEEE double precision. So this lecture will be delivered in Filipino English for your assist with your learnings. So without further ado, let's get started. Okay, so nung nakaraan, diniscuss natin yung IEEE single precision. So from decimal, ginawa natin IEEE single precision. Then, yung IEEE single precision, ginawa natin siyang decimal or binary. So, this time naman, we'll discuss yung double precision. So, bakit natin kailangan discuss yung double precision na yan? Okay. So, suppose yung mantisa natin is ganito siya. Ang haba. So, di ba nga, ang ginagawa natin dyan, pag masyadong mahaba, we truncate. Pinuputol natin yung certain part. Thus meron tayong term na tinatawag na truncation. Wherein yung pinuputol natin yung other part. Or, ginagawa natin, we move that and then that one bit to another para mapahaba siya. Okay. So, just to have more precision or mas maging accurate yung data natin. So, what if, so, in IEEE single float, we only have 32 bits to represent that. And if 32 bits is not enough to represent that, how do we make it more accurate? So, paano natin siya magagawang mas accurate? So, ang kasagutan dyan, dinevise ng mga past engineers or mga past computer scientists natin, na kung hindi sapat si 32-bit, why not represent it sa natawag natin na 64-bit? Kaya na-invento or nangyari, nabuhay yung konsepto ni IEEE double precision. Which is, eto ngayon yung i-discuss natin sa may part na to ng ating lecture. So, si IEEE double precision is parang si IEEE single precision. Kung si IEEE single precision or 32-bit, meron siyang sign bit sa pinakauna, ganun din si IEEE double precision. Tingnan natin. So, gawin natin ng comparison, barahin ko lang to. Mas compare natin. So, compare natin ha. So, IEEE single precision versus IEEE double precision. So, single precision, okay, this is a sign bit isa. Sa double precision, sign bit isa din. So, that is the sign bit. So, sign bit niya rin ito. Si IEEE single precision, meron siyang ilang bits ito? Meron itong 8 bits. Whereas IEEE double precision, we have here 11 bits. Ito yung normalized exponent. Same with this one. This is the normalized exponent. And, of course, the last part. So we have here 23 bits of mantisa. Whereas, in IEEE double precision, we have there 52 bits per mantisa. So, all in IEEE single precision, that is 32-bit. Sorry for that. So, 32 bits ang kanyang ang kanyang range. Whereas in IEEE double precision, yan ay 64 bits. Kumbaga, dumoble yung capacity niya. Okay. So halos pareho lang din ang pag-solve ng IEEE double precision. Pero ano lang ba ang nabago? Ang nabago lang dyan, etong normalized exponent ay naging 11-bit instead of 8 bits. So kung nagbago ang normalized exponent at lumaki yan, kung si IEEE single precision ay merong 127 plus E para maging normalized, si IEEE double precision meron siyang 1023 plus E para maging normalized. So yan lang yung mga importanteng concept na dapat nyong maalala sa may discussion na to. Okay, so makita nyo comparison ng dalawa. Okay, so hope nakuha nyo yung mga importanteng bagay dyan. Okay, ngayon, let's have some example. Converting yung decimal papunta ng IEEE double precision. Okay, ito na. So let's have our first example. So for our first example, let's have represent negative 12.125 in IEEE double precision. Alright. So, i-represent daw natin yan sa IEEE double precision. So, what's the first thing to do? Okay. Inspect the sign bit. So, negative. Of course, ang sign bit na natin will be positive. So, that would, negative. I'm sorry, not positive. So, negative, that would be 1. Okay. Pagka 0, that is positive. And then, express this to decimal. So, 12.125. So 12 in decimal, so that is simply 1, 1, 0, 0. And then 125. So 0.125 times 2. So that is 0.25. So 2 times 0.125. So that is 0.25. And then 2 times 0.25, so that is 0.5. And then 2 times 0.5 is equals to 1.00. And then, that would mean, tuloy-tuloy na 0 to. And this would mean na ito ay isang exact value. So, that would be 001. Okay. So, nakuha na natin yung value niyan. So, 1100.001. So, what's next? Just like what we did with single precision, i-express natin siya as a binary scientific notation. So moving 3 places to the left, that would mean positive 3. So that would be 1.100001 times 2 raised to 3. Okay. So yung 3 yung ating exponent. Alright. So how do we normalize that? Kung si IEEE single precision is 127 plus E, remember, kasabi ko lang kanina, si double precision, that would be 1023 plus E para maging normalized na siya. So for that, so 1023 plus E plus 3 is equal to 1026. Ito na ngayon yung normalized value natin. So 1026, express natin siya ngayon sa decimal. Ganun pa rin yung steps, na iba lang yung mga formula. Okay. Yung decimal, express natin to binary. I'm sorry for that. So medyo na-interchange yung dalawa minsan. So 11-bit binary, itong 1026 na decimal. Okay. So yung 10, so, yan, sige, kunin muna. Ito. So hope na copy nyo na, take down notes nyo. So 1026. So we convert 1026 to decimal. Okay. Per month. So kunin mo natin importanteng value. So mantisa is 100,001. Okay. Kunin mo natin yan. So mantisa is 100,001. Okay. So mantisa is equals to 100,001. So ito yung mantisa natin. So, 1026, okay, convert natin siya to binary. So, divided by 2, so that will be 5, 1, and 3. Walang remainder. So, 2, 2, and 6, may isang remainder. So, 1, 1, and 3, walang remainder. Wait lang ah. Alright, tama. Wait. So, 5, 1, so it's correct. So, 26, 10, correct. So, divided by 2, so that is 2, then 5, and then 6. So, remainder 1. 256 divided by 2, so 1. So, 2, and then 8, so 0. 128 divided by 2, so that is 64, 0. 64 divided by 2, so 32, 0. 32 divided by, not 3, but rather 2. So that is 16, so that is 0. 16 and 2, so that is 8, 0. 8 and 2, so that is 4, 0. 4 and 2, so that is 2, 0. And then 2 and 2, so that is 1 and then 0. All right. So, reading that upwards, so that would be 1, 0, 1, 2, 3, 4, 5, 6, 6 zeros. And then 1, 0. So, 11 bits ba lahat yan? Count na natin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, 11 bits dapat siya. So 1, 0. Okay. Kulang tayo ng isang 0 pala dito. Kaya pala. So, 1, 0. Then, tatlong 0. Then, another tatlong 0. Okay, then 0, 1, 0. Okay. So, medyo nakakadulang lang. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 11 bits. So, that's correct. Meaning to say, okay. So, nakuha na natin ngayon yung 11-bit exponent. Okay. So, ang value natin is negative 12.125. So, ito yung value natin kanina. Okay, yung example value natin. So, negative, so that would be 1. Then, take this 1, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0. Tama ba? 4, 5, 6, 7, 8, 9, 10, 11. Okay. And then, the mantisa, 1, 0, 0, 0, 0, 1. And then, 1, 2, 3, 4, 5, 6. Kung 6 na yan, ilan pa kailangan para maging 52 siya? 6. Okay. So, the remaining will be padded with zeros, just like what we did in a single precision. So, 0 hanggang sa umabot sa may 64th na bit. So, ganyan lang natin siya i-convert sa IEEE double precision. And this is now the answer in binary. So, if you want to express that in hexadecimal, pwede rin. So, gagawin mo lang, i-divide mo rin siya into 4. So, for that case, that would be, so 1, so 12, 12 is 1. So, 12 is C, then this is 0, this is 2, this is 8, this is 4, and then 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, then up to the last, then H. So, ganun lang natin siya gawin or ganun lang natin siyang isolve. Alright? So, hope nakita nyo yung naging difference lang niya, but the process is still the same. Nang nangyari lang is nag-iba lang yung mga formula and yung kanyang syntax o yung pinaka-format. Okay. So, let's now have another example. So, gawin naman natin, from double precision, babalik natin siya into a decimal. So, express, we're going to write example 2. So, express, so that would be 3FBD. So, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. Oh, a lot of zeros in here. 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12. Let me see if that's correct. So, 4 times how? 4 times 16, so how many? Sorry for that. So 4 times 16. So that should be 16 times 4. So 4 times 6, so that is 4 carry 2, so 64. So that's correct. Okay. So tama yung representation natin in hexadecimal. So I'm going to erase this na. Express in decimal. All right. So 3 is 0011. F is 1111. B is 11, so therefore 1011. And then D is 11, C is 12, D is 13. 13, so 10, 1, 1, 0, and 1. Okay, so those are the representations. So we're going to now represent that in terms of this format. So we have here 0, 1, or sorry, 0, 0, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. And then the rest are zeros. Okay. So, pwede yung i-shorthand na ganyan pag nasa solution as long as walang madamay na values. Okay. Same process, isolate the sign bits. 0, that means positive. 0, 1, 1, 1, 1, 1, 1. Okay, so kailangan natin mag-count dito ng 11 bits. So 3 plus 4 is 7, plus 4 is 11. So ibig sabihin hanggang dito ang ating sign bit. Alright. So what we're going to do is to convert this back to, recalling yung IEEE single precision. Okay, we convert this back to decimal. So 0, 1, 1, we'll use doubling to convert that back. So, wait kasi ako. Sorry for that. Okay, so ayan yung mga values. Okay. And then plus, so I think I'm going to change the color of my pen. So in that part. So I think red will suffice. Okay, mas nakita ang red, kita din ang red dito. Okay, so I'll just use red. So 0, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1. Okay. Hindi rin kita. Anyways. So, maybe I'll just write it here. Para mas makita nyo. For the sake na nakita lang ninyo. Okay. So 1, or I'm sorry, 0, 1, 1, 1. 1, 1, 1, 1, 0, and 1, 1. So plus, 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 plus. And then 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Times, 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 and times. All right. So 0 on the upper bit. So this is equal to 0. So 0 times 2, so 0 again. So 1. 1 times 2 is 2 plus 1. So that, therefore, that is 3. 3 times 2 is 6 plus 1. So that is 7. 7 times 2 is 14 times 1, so 15. 15 times 2 is 30 plus 1, so that is 31. 31 times 2, so 62 plus 1, so 63. 63 times 2, so that is 126 plus 1, so 127. 127 times 2, so that is 254 plus 0, so it's still 254. So 254 times 2, so that is so 8, 0, carry 1, 508 plus 1, so 509. And 509 times 2, 509 times 2, so that is 1018 plus 1. So 18 plus 1, so that is 1019. Okay, so 1019. So that's correct. So we already have the value, so 1019. So after we get that, So may tan 19 na tayo. Ngayon, kunin natin yung denormalized value niya. So how do we get that? So 'di ba nga, the formula for normalizing is 1023 plus E, that would be the normalized value. So gawin natin, hanapin natin si E. So that E would then be equal to the normalized value minus 1023. And for that case, the E would then be equal to 1019 minus 1023. And E would then be equal to negative 4. Okay. So negative 4 ang E natin, ang mantisa natin ay ito. Okay. So what's the next step? Pahin natin to, may space. So mantisa is 1101. Okay. Katulad ng ginagawa natin kay single precision, ina-append natin ng dot at saka ng 1. Ano yung notation? Raised to negative 4. So pag negative 4, anong mangyayari? So atras sa ngayon, papunta doon sa may left. So therefore, we'll move that 4 decimal places papunta dito. So 1, 2, 3, 4. And then 0.0. So ngayon, ang mangyayari, ito na ngayon yung value ng ating nire-represent in binary. So that would be 0.0001. 1101. So, binary pa lang ito. Kailangan natin yung decimal. And not unless sinabi ko na okay ng decimal. Okay, so, how do we convert that back to decimal? Okay, so we'll apply the principle of yung doubling na tinura ko na pang fraction. So, sana naalala nyo kasi hindi nakikita yun sa mga books. Alright. So, 0 over 2. Ayusin lang natin sulat. 0 over 2. 0 over 2, 0 over 2, 1 over 2, 1 over 2, 1 over 2, 0 over 2, and 1 over 2. And then, lagyan natin ng space. Plus, 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 and plus, 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 and plus. Alright. And then, this is 2 over 2. So 2 over 2. Then, on the topmost bit, 0. And this would be 1 over 1. So since 0 to at 0 ito, therefore the answer here is 0. So for this case, 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over, not 1 over 3, but rather 1 over 4 here. 1 over 8, 1 over 16, 1 over 32, 1 over 64, and 1 over 128. Okay, so, yan lang yung mga yung mga cases na anuhin natin dyan. Okay. So, 0 ito. So, we put 0 here. So, 0 pa din ito. 1 half and 0. So, 0 pa rin siya. So, 0. So, 0, 2 over 2. Okay, so 0 pa din siya. And then 0 ito. So, 0 pa rin siya. So, 0 here. So, 0 ito. 1/8 and 1 half. Okay, so that is 1 over 16. Copy 1 over 16 here. 1/16 times 2. So, 2 over 16 plus 2 over 32. Sorry. Plus 1 over 32. So, that is 3 over 32. Then you put 3 over 32 here. So 3 times 2 is 6. 6 over 64 plus 1 over 64. So that is 7 over 64. So 7 over 64, put it here. 1 over 64 and 0 over 2. So magiging 0. Ito makakancel out. So that would be 14 over 128. And then lastly, 14 over 128 times 2 over 2 plus 1 over 2, 128 times 1 half. So 14 times 2 is 28. 256 plus 1. So 14 times 2, so that is 28 plus 1. So that is 29 over 256. And that is now the representation in fraction. But if you want the decimal format, you simply divide 29 by 256, and that will lead to 0.11328,125. And both are the answers. So, ganyan lang natin siya kadaling nakukuha. And don't forget the sign. So, since positive siya kanina or zero siya, that would mean the answer is positive. Okay. So, therefore, the answer is positive 0.11328,125. And that is now the answer. Okay? So, tingnan nyo na lang ito. Yan. So, in solution, hope nakikita ninyo. Alright? But before I leave, I want to share you something. Before I leave with this discussion, I want to share you with something. So, meron tayong tinatawag na special cases. So, pag ang E natin ay 0, and then ang mantisa natin ay 0 din. Therefore, the value would then be equal to 0. That's the first case. Special cases ito ng IEEE representation. Second representation or second condition, pag ang exponent natin ay equal sa 255 at ang mantisa natin ay equal sa 0. Therefore, ang value natin ay infinite. So, positive, negative, infinity. And then for the third condition, if the exponent is 255 and hindi 0 ang m natin, therefore, the number is non-existent. So, pag nakita niyo itong mga condition na to sa representation, so, agad-agad yun na may kita yung sagot. So, pag parehong 0, so 0, 255 and 0, infinity. Pag 255 and not 0 yung mantisa, that means non-existent yung number. So, yun lang yung mga dapat niyong tandaan dyan. Alright, so that concludes the data representation lecture series part 2. So I hope you learned something new in this discussion. So if you have problems and you can hardly grasp the knowledge in this discussion, so kindly repeat the video again and again until you can get the necessary knowledge. So if there are problems or concerns that cannot be answered by that method, so kindly reach out to me and don't be afraid to reach out to me. Alright, so hope you're enjoying the lectures. See you at the next lecture series.